Hello everyone. In this video, we will be solving the numerical problem based on work done calculation. Here in this question, we are asked to find the work done in moving the charge of 4 coulomb from initial position is B with coordinates 1, 0, 0 to the final position is A, 0, 2, 0. Along the path, equation of the path is specified and 3 different electric field intensities are given. We are asked to find for these 3 cases what is the expression for work done and how to compute the work done and what is the answer for work done. We are going to do that one by one and find the answer. So the charge Q given is 4 coulomb and the initial position B is 1, 0, 0 and the final position A is 0, 2, 0. The formula is work done is minus Q, line integration, E vector dot dl vector. This is the initial position and this is the final position. So let us do for the first subdivision. First, let us find what is E dot dl in each case and then we can do the computation. E dot dl will be, in this case, E vector is 5 ax cap volt per meter. In rectangular system of coordinates, dl vector is dx ax cap plus dy ay cap plus dz az cap. We should now estimate what is dot product, which is going to be 5 dx plus 0 plus 0. So the work done can be found as minus 4 into integration 5 dx, where the limits of x, lower limit and upper limit should be written. So the initial position is at B and final position is at A. So the limit for x is from 1 to 0. So let us find this answer, which is minus 4 into 5 x 1 to 0, which is minus 4 into 5 into minus 1, that is going to be 20 joules. So this is the amount of work done for the first electric field intensity vector given. Now let us consider the second electric field intensity vector, that is the second subdivision, where electric field vector E is 5x ax cap. So 5x ax cap. We know same dl vector. So we can write E vector dot dl vector is 5x dx plus 0 plus 0. Now here the work done can be computed as minus 4 into integration 5x dx, where x limit is from 1 to 0. Now in this case, we should be finding the work done, that is minus 4 into 5 by 2 into 0 minus 1. This is going to be something good stuff here. Okay, so this is going to be 1 times 2 times, which is 10 joules. So work done for the second subdivision is 10 joules. Next, the third subdivision, we should do the vector E is 5x ax cap, then 5 by ay cap. This is the vector E for third subdivision. We'll be doing that. Third subdivision, vector E is 5x ax cap, then 5 by ay cap volt per meter. So we should compute E dot dl vector, which is going to be 5x dx plus 5y dy plus 0. Now work done can be found as minus 4 into 5x dx integration, x limit is from 1 to 0, then 5y dy, where y limit should be taken from, let me check, 0 to 2. So for y limit, it is 0 to 2. So y limit is 0 to 2. We should perform this integration. So minus 4 into 5 x squared by 2 limits 1 to 0. Then here 5y squared by 2 0 to 2. So that is going to be minus 4 into here 5 by 2 into 0 minus 1 plus 5 by 2 into here 4 minus 0. So that we can write it as minus 4 times 5 by 2 is common, and you have minus 1 plus 4, that is 3. So this is becoming 3. So we will be getting 30 joules. So work done for the third case is minus 30 joules. So this is how we should solve this problem. I hope you have understood this problem. Thanks for watching the video.